Hello everyone, in previous classes we are discussing about the electromagnetic radiation in the form of waves, and we are also studying about their properties, and next the different types of an electromagnetic radiations or electromagnetic waves according to their wavelength and their frequencies. So on the basis of that concept, in today's class I wish to discussing about the numericals on the basis of that electromagnetic radiation or the waves. And already you know about these electromagnetic radiation or these electromagnetic waves are characterized by some points like a frequency, wavelength and wave number, velocity means like a speed of a light. So by using these help of these points we are characterized our electromagnetic radiation. So see here, the first numerical or the first problem is the Vivid Bharati station of an All India Radio Delhi broadcast on a frequency of 1368 kHz calculate the wavelength of an electromagnetic radiation emitted by a transmitter. Which part of electromagnetic spectrum does it belong to? So see here we have two questions. It is our main question and it is our sub part question is also added to this. So what they are saying to us, the Vivid Bharati station of All India Radio Delhi broadcast a frequency of 1368 kHz. They broadcast this much frequency of wave. So they give us the frequency. So frequency we are denoted by nu. The frequency is how much? They give 1368 kHz. And next, calculate the wavelength of electromagnetic radiation. What they asked to us? Wavelength. Calculate the wavelength of electromagnetic radiation emitted by the transmitter. So the lambda, we don't know about the wavelength. Wavelength is denoted as a lambda. Already you know that. That's why lambda is equals to question mark. And next, again what the sub question is, which part of an electromagnetic spectrum does it belong to? On the basis of their wavelength or on the basis of their frequency, we can say which type of electromagnetic spectrum is this. So the electromagnetic spectrum does it belong to, like is it belong to a gamma rays or X-rays and visible region, radio waves and microwaves, like different kinds of regions are there in electromagnetic spectrum, in which part these are or these waves are belongs to, they ask to us. So we will see later about this part. First we see this first one. What they are asked, they give a frequency to us and they asked about the wavelength. Already you know that this formula C is equals to lambda mu. C is equals to lambda mu. So this, remember this formula. So this is help in all problems related with the electromagnetic radiation or electromagnetic waves. So this is your NCERT book question. And see here, we know the value of C. Why? Because it is the value of the speed of light in a vacuum. Anytime, wherever its value is constant. So what's the C is here? 3 into 10 raised to 8 meter per second. 8 meter per second. So this is the speed of light in a vacuum. And next we know the value of C and we know the value of frequency. Just we want lambda. So see here, lambda is equals to C divided by mu. Then what happened here? Just put it these values and simplify, you got the answer. So this is very simple calculation. Just take the values. What is the C? 3 into 10 raised to 8 meter per second divided by, and what is our nu? 1368 kilohertz. Kilo means I can write into 10 raised to 3 hertz. Can I write 10 raised to 3 hertz? Because in the first chapter, you already know that the kilo means, what's that value is? 10 raised to 3. So see here, 3 by 1, 368. More about, you got 0.002192 into 10 raised to 8. When this 3 comes here, then it may be a 8 minus 3, because already you know that a raised to m divided by a raised to n is equals to a raised to m minus n. Already you know that. So see here, 10 raised to 8, 10 raised to 3 means it is in the form of a raised to m, a raised to n. Then what happened? A raised to m minus n, 8 minus 3. Then what will be the answer here? 0.02192 into 10 raised to 8 minus 3 is 5, 10 raised to 5. And next, so see here, I shift this point 1, 2, 3, 4, 5 to 19.2 into 10 raised, so 5, I will put this decimal up to the 5 points, 1, 2, 3, 4, 5. So 219.2 meter. This is our answer. So how much meter is the wavelength of this kilohertz waves? So 219.2 meter. So lambda or wavelength will measured in terms of the meter here. So this is a very long wavelength. Already I told you in a previous class, a very long wavelength are related to the broadcasting area like microwaves and radio waves. A very long wavelengths are belongs to the radio waves. So these are, so next part of the question answer is, these are belongs to the radio waves. Radio waves. Radio waves. So see here, the radio waves are belongs to this part of this wavelength. So this is your answer. And once I wish to repeat the problem here. Here what they ask, the wavelength of the electromagnetic radiation lambda, and what they give, the frequency of the nu. So then we now already the value of C, then by using the lambda is equals to C by mu, we put it the value and simplify this problem, then we got the answer. So this is our next problem. The wavelength range of visible spectrum extends from a violet up to 400 nanometer to the red 750 nanometer. Express these wavelengths in frequencies. Just I wish to recap some points about this problem. In a electromagnetic spectrum, we see the region that is a visible region. So visible region. This region electromagnetic radiations are only we see in our naked eyes. And this visible region is made by the 7 colors like Vibgayar means violet, indigo, blue, grey, yellow, orange and red. And these colored regions we can see in between the nanometers or in between the wavelengths up to 400 nanometer to 750 nanometer. So they given the data to us in terms of the wavelengths and they asked express these wavelengths in terms of the frequencies. So see here I use the term nanometer. So what is the meaning of nanometer here? The 1 nanometer means 1 into 10 raised to minus 9 meter. 10 raised to minus 9 meter. Next we are moving with our problem. So come here. First, I wish to express the wavelength of violet color in terms of the frequency, means in terms of hertz. So, violet color, first we have to go with the violet. So, see here the violet wavelength is they given to us, that is up to a 400 nanometer, and I write this is in terms of a meter, 400 into 10 raised to minus 9 meter, because the nanometer means 10 raised to minus 9 here. And this way now the formula C is equals to mu into lambda. C is equals to mu into lambda. So, what we want now in this equation, we want the frequencies. So, frequency is in terms of a nu. So, nu is equals to C by lambda. So, this is our formula which is applied here. So, see here the mu is equals to C means already you know that in the vacuum the speed of light is 3 into 10 raised to 8 meter per second, 8 meter per second, and then put the values, got the answer. It is also very simple to us. C is equals to 3 into 10 raised to 8 meter per second divided by the lambda. Lambda means 400 into 10 raised to minus 9 meter. Then 3 divided by 400 is up to 0.0075 into, then see here 10 raised to 8 and 10 raised to minus 9. So, this is in the form of a raised to m divided by a raised to n. Then what happened? A raised to m minus n. A raised to m minus n. And next see here 10 raised to 8 minus 9. Then minus into minus is plus. Then what happened? 10 raised to 17. We got 10 raised to 17. And next is 0.0075 into 10 raised to 17. I shift this decimal point to the right side, 7.123. So, I shift 3 points, 7.5 into 10 raised to 14 hertz, into 10 raised to 14 hertz. So, this is the answer, 7.5 into 10 raised to 14 hertz. In terms of frequencies, we can express these value. And next, we are moving with our red color region. So, red color region, we have the value 750 nanometer. 750 nanometer means 750 into 10 raised to minus 9. Here also, we apply the same formula here. So, then mu is equals to C means here already we have 3 into 10 raised to 8 divided by lambda. So, for a red 750 nanometer, 750 into 10 raised to minus 9. Again we got the answer 10 raised to 17. And 3 by 750 is equals to 0.004, 0.004 into 10 raised to 17. Then again I shift this point, 4.00 into 10 raised to 14, 10 raised to 14 hertz. So, this is our answer. I hope you got very clear concept about this problem. And next problem is this is our next problem. Calculate wave number and frequency of LO radiation having a wavelength 5800 angstrom. In a previous question, they given the wavelength in terms of a nanometer. Then what you write there? 10 raised to minus 9. So, the nanometer meaning. Here what they given to us? They are given to us the wavelength in terms of a angstrom. So, what is the meaning of an angstrom here? So, 1 angstrom is equals to 1 into 10 raised to minus 10 meter. You got it? Then write. So, So see here, what they given to us, they give us a lambda is equals to 5800 angstrom. We convert them into a meter like 5800 into 10 raised to minus 10 meter. And then what they are asked to us, they ask frequency. They asked to us a frequency and wave number. First we have to express or we have to calculate about the wave number here. So wave number means nu bar. Nu bar is the wave number they asked to us. Already you know that the wave number is a reciprocal of a wavelength. So mu bar is equals to 1 by lambda. Then put the value here, 1 divided by 5800 into 10 raised to minus 10 meter. Then the value is up to 0.000172 into 10 raised to 10 meter inverse, because it is a reciprocal. Then what happened, I wish to put this decimal point after a 4 digit 1, 2, 3, 4, 1.72 into, then what will be the answer here? 10 minus 4, because I shifted the 4 digit here, 6 meter inverse. So this is our answer. If I write this answer in terms of a centimeter, then what happened? 1.72 into 10 raised to 4 meter inverse, because centi means 10 raised to minus 2. 6 minus 2 is 4. So this is our value here. And next one is, so see here, what they asked to us, the frequency of LO radiation. They asked a frequency, they asked mu, and they give lambda. So what is that? Lambda 5800 into 10 raised to minus 10 meter. Already you know that C is equals to mu into lambda. Then what they asked to us, mu, then C is equals C by lambda. Then put the values, C 3 into 10 raised to 8 meter per second, 8 meter per second. This is the value of light presence in a vacuum. Then lambda, what is the value of lambda here? See, 5800 into 10 raised to minus 10 meter. Then cancel. 3 by 5800, this is 0.0005 something is like that, 517 into 10 raised to 10 into 10 raised to 10 per second. So see here, I wish to put or I wish to shift this decimal point after 4 digit. Then 5.17 into 10 raised to 14 per second. So this is our value. This is our answer. Next, I hope you got clear about these numericals based on the electromagnetic radiation. In our next class, I wish to tell about the electromagnetic radiation in terms of particles.